All right, so now we're going to talk about a couple cases where the law of signs can get a little more interesting. So this is called the ambiguous case of the law of signs, and it's mainly going to impact us, or it's fully going to impact us when we're in the SSA, or the side-side angle case. Okay, and what's going to happen for this ambiguous case is sometimes when we have side-side angle, it turns out that we can get 0 triangles that will meet, that will actually make a triangle. We can get 1 triangle that fits it, or we can actually end up with 2 triangles. Now, if that seems a little bit confusing, don't worry. We're going to look at a little app here and kind of see what we mean by that. Okay, so in this app, notice what we can do is we can work on making triangles. And when we actually make a triangle, okay, we get a little thing that pops up that says, you made a triangle. There it is, you made a triangle. Okay, in other words, we connected the dots and we made a triangle. Okay, so we're going to investigate a case of side-side angle, where we have a side that is 15, so that's our green side here. We have a side that's 7, that's our red side here. So side, side, angle, and we're going to make this angle, this A, 30 degrees. So I'm going to move this until it's 30 degrees. So again, we're inside, the red side, the green side, and then angle. So what can we change? We can change the length of the purple side, and we can also change angle B, and our goal is to make a triangle, okay, just by changing those things, okay? But the problem is, I don't think there's any way that I can get, no matter where I put this, there's just no way that this red side is gonna reach that purple point C to make a triangle. So this actually doesn't make a triangle, okay? So what does this mean for the law of signs? In other words, what if I put this situation into the law of signs? What happens? All right, so in the video, we had on the triangle app, we had 30 degrees for A, our little a, our side length A was 7, and our side length B was 16. When we plug that into the law of signs, let's see what happens. So we know that our A is 30, so we have sine of 30 over 7 has to equal sine of B over 16. So we're trying to solve for sine of B. I can solve for sine of B by multiplying both sides by 16. So I get 16 times sine of 30 over 7 equals sine of B. Okay, all right, well, what is sine of 30? Sine of 30 we can get by going to our unit circle, right? So if you have your unit circle handy, great. If not, here it is. So 30 degrees is right here. Sine of 30 is 1/2. Okay. So we have 16 times 1/2 over 7 equals our sine of B. But 16 times 1/2 is 8. 8 divided by 7 is, we're just going to leave that as 8/7. So we have 8/7 equals sine of B. Now this is a problem. Why is this a problem? Well, it's a problem because 8/7 is bigger than 1, right? This is a number that's bigger than 1. But think about our sine graph. Sine goes from -1 to 1. So can sine of something ever be bigger than 1? No. Another way of saying this is the range of sine is -1 to 1, meaning sine can never spit something out that's bigger than 1. So this has no solutions, okay? This has no solutions. Now, if you were to stick this in your calculator would also say error. It'd probably say something like a domain error or range error, depending on calculator model. Either way, there is no triangle that exists that has these properties, okay, that has an angle of 30, a side length 7, and a side length 16. So no triangle. So no triangle exists with those. So this is one example of the ambiguous case. Okay, we get no triangle. There's no such triangle that meets this angle side side or side side angle definition. Now, I said there were several possibilities. One was that no triangle existed. One was that one triangle existed. That's a pretty standard case. The other is that there could be 2 triangles that meet a set of criteria when we're given that criteria side side angle. So let's go back to our triangle creator and look at an example of that. Okay, so now we're still looking at that ambiguous case of signs where we have side side angle. And so now our angle is staying 30. We've made this side 8 and this side 5. So we've got side, side, angle. And again, we're going to try and make some triangles. Okay, the only thing I can change is the length of my third side, and then the size of angle B. Notice that that's also changing angle C. And our goal is to see if we can make a triangle out of this. Okay, all right, so let's see what we can do. Well, I think we can get a triangle here. Whoa, it's doing some weird zooming stuff, sorry. Probably because a cat's stepping on the keyboard. Cool. All right, there, we made a triangle. Okay, awesome. So there's one triangle that we can make, okay, with this 5, 8, and 30 degrees. But I think there's also another triangle we can make. So let's see if we can make another triangle. Okay, so if I move this guy in, and I'm gonna expand, there we go. So there is a second triangle we can make. Okay, so we actually made 2 triangles with the values 5, 8, and 30 degrees. Okay, so this is also an ambiguous case because we don't get one distinct answer. We actually ended up with 2 answers. So let's take a look on the board at this example and what happens when we plug it into our law of sines. Okay, all right, so the second example that we were looking at, we had that our A was 30 degrees. We had that our side A was 5 and our side B was equal to 8. Okay, so now when we plug into our law of sines, we'll have sine of 30 over 5 equals sine of B over 8. We're going to solve this for sine of B. I'm going to multiply both sides by 8, so that gives me 8 sine of 30 over 5 equals sine of B. Okay, sine of 30 is 1/2. 1/2 times 8 is 4, so we get 4/5 equals sine of B. Now, 4/5 is not going to be one of the nice numbers on our unit circle. So in order to find sine of B, when sine of B is equal to 4/5, we're going to use our inverse sine or our arc sine in our calculator. So I'm going to take arc sine or inverse sine of both sides of this. Okay. So that tells me that arc sine, also known as sine inverse, I'm using those two interchangeably, is going to be equal to B. Okay, so let's go ahead and go to our calculator and see what we get. All right, so here we are in our calculator. I'm going to quickly check that I'm in degrees, which I am. Okay, and then I want to do inverse sine, sine to -1 of 4/5. Okay, now this spits out an answer of 53 degrees. Okay, 53.13 degrees. I'm going to round that to 53 degrees for this argument. Okay, so we got one answer out of this, 53 degrees. But I'm making the claim that there's actually 2 answers present here. So this tells us that B equals 53 degrees. Okay, well, here's the thing. If we have 53 degrees, we know that there's another angle that is going to meet the sine of this. So what do I mean by that? We think about our sine. We think about our sine function, okay? And we think about what we did in some of the other videos, right? We usually have 2 values, right? 2 angles where we get sine of some number, right? So think about this. If we had something like sine of some x was equal to 1/2, okay? If we're thinking about our whole unit circle, or we're thinking about a triangular case, there's actually 2 values that satisfy this, sine of x equals 1/2, right? The first is 30 degrees. We just talked about that. But where is the other value on our unit circle where sine is equal to 30 degrees? Well, if we think about sine being our y, right? So if this is 30 degrees, then somewhere over here, kind of that matching angle over here, sine of this angle will also be 1/2. And what is that? Well, that's 150 degrees. Okay? In other words, the supplement to 30 degrees. So let's look at this. Is there a supplement to this? What would the supplement to this be? Well, it'd be 180 minus 53. 180 minus 53 is, let's see, 30, 127, right? B equals 127 degrees, okay? All right, does that seem reasonable? Let's think about the triangles that we made, okay? Did we make a triangle where B was 53 degrees? And did we make a triangle where B was 127 degrees? In all honesty, I wasn't really paying attention. So let's hop back to our triangle creator and check that. 53 degrees and 127 degrees. Well, luckily, one of our triangles, is up there, and it sure is at 53 degrees. The other triangle we made, if I remember correctly, we moved way back here and matched our little guys right there. Look at that, it's right at 127 degrees. So there are 2 triangles. One happens to be acute, one happens to be obtuse in this case. where we can make a triangle using that 5, 8, and 30 degrees, okay? So for this case, right, there are actually 2 triangles that meet these criteria. Weird. Okay? So we could get no triangles when we have side-side angle. We could get 2 triangles when we have side-side angle. Well, we could also get just 1 triangle. Okay. So let's look at that. I'm going to go ahead and keep track of what our angle B was here. So our angle B was either 53 degrees or our angle B was 127 degrees. Here our angle B didn't exist. So I'm going to write that as the empty set. That's not 0, that means empty set, because we couldn't build a triangle to make B work. Okay. Now let's look at one more case. So let's go back to our triangle creator here. All right, for this last example, we're again going to keep our angle A at 30, and then we're going to do our side B as 5 and our side A as 6. So we're still in side-side angle, and our goal is to see if we can make a triangle by changing angle B and also the length of C. Okay, well, it's going to be tough for me to make a triangle by moving B in this way, so I better move my B out this way. Looks like there's my best bet. When I rotate, oh, yay, we made a triangle. So we got a triangle when our B was 24 degrees, and it sure looks like that's going to be the only triangle that we can possibly make with this guy. Okay, so let's put that guy up on the board. All right, so here's the example now. A is 30 degrees, A is 6, B is 5. So using our law of sines, we would have sine of 30 over 6 equals sine of B over 5. So that tells me that 5 times sine of A over 6, sine of 30, sorry, A is 30, equals sine of B, or 5 times 1/2, 5 halves, so we can just do 5/6 times 1/2, which is 5/12 equals sine of B. So again, 5/12 is not something that we're going to find on our unit circle. So instead, we're going to have to use a calculator. So let's go to our calculator. We already know we're in radians, so we'll do inverse sine of 5/12. And we get 24.6 degrees, which I'm going to go ahead and round up to 25 degrees. We saw in our little applet 24 degrees. That's pretty close, considering that we were just kind of eyeballing where these things made triangles. Okay, so we got 24 or 25 degrees. We'll say 25 degrees for our B. Okay, all right, so these are the 3 possible cases when we're using side-side angle. If we get side-side angle, we could have no triangle that meets that. We could have 2 triangles that meets those kind of descriptions. Or we could have 1 triangle that meets those descriptions. Okay, the question is, how do we know? How do we know when we have 0, when we have 2, or when we have 1? Okay, so that's what we want to explore here. So with this first case where we had no triangle, right, if we kind of sketch out what this might look like. Okay, here's angle A, up here's angle C, up here's angle B. Okay, we knew our angle A, and we knew our C, and the way we were building it, we also had our A coming up here. And what happened is our A was just too short. No matter how we rotated this side A, we could never get it to meet up with this guy. So we just didn't get a triangle that existed that way. Okay? With this guy, we actually got 2 triangles, right? How did that happen? Well, if I again sketch our little scenario here, let's start. If I sketch our little scenario here, right? We had our A and our B and our C up here. We knew angle A, we knew side length B, and we also had, right, this guy. And it turned out that there were 2 different ways we could make this triangle, right? We could come down like this to build this triangle, or we could also come down like this to build this triangle. Notice that that gives us either an obtuse triangle, that's when we got the 127 degrees, or an acute triangle, that's when we got the 53 degrees, okay? And in our last case, well, our last case is just a well-defined triangle. There was only one way that we could sort of connect all of the pieces together, okay? Now, the good news is, if we can have a case where we get no triangles, well, our algebra will actually show us the work, right? It'll be like, hey, you don't have an answer. That doesn't make any sense. You'll get something like sine of one of your angles equals something that's bigger than 1, okay? And that just doesn't work. That's impossible. In the case of one triangle, well, we'll just get one answer and we don't have to worry about it. It's the case of 2 different triangles that we have to think about, okay? So we're going to let the case of no triangle take care of itself because it's going to kind of come out in the calculations. Okay? But what about these two? How do we know when we have one answer versus two answer? Well, the answer is in what you get first. Okay? So here, we could get two triangles because we could get an obtuse triangle and we could get an acute triangle. Okay? In other words, when we take the angle that we got from our calculation, we got 53 degrees. When we look at the supplement of that, 127 degrees, that could also make an angle. Sorry, of course it could make an angle. That could also make a triangle. Okay? In other words, 53 and 30 plus that third angle would make a triangle. 127 and 30 plus our third angle C would make a triangle. Now, if that seems confusing, it's okay. Hopefully it'll make sense when we look at this guy. What's the supplement to 25 degrees? In other words, what's our other possible angle for a triangle? Well, that would be 180 minus 25, which is 180 minus 25, 180 minus 20 is 160, minus 5 is 155. Okay, we have a problem. So this is the other possibility if we were going to have two triangles. Okay? Why can this angle B not be an angle in our triangle? To answer that question, come back up to this angle, angle A. If these were two angles in a triangle, could it be a triangle? No, because if I add these together, 30 and 155, I'm already at 185. That's already more than I'd have for a triangle, okay? So this simply doesn't work, okay? So when you're working with law of sines and side-side angle case, okay, one thing that you can do is you can kind of just work through it the way you normally would work through a problem, okay? If you get an answer that doesn't make sense, or if you get a calculator error, or if you get something that you recognize as not having a solution, such as sine of some angle is something bigger than 1, well, then you're in the no triangle case, okay? If you get an answer, right, so you work through it, you get an answer, figure out what the supplement to that answer is, and then ask yourself, could that also be a triangle? If it could, then you're in the case where you have two triangles. Okay? Let's go ahead and work at least one more example of this ambiguous case. All right, so here's our next example. B is 31 degrees, B is 8, C is 13. So we're definitely in the side-side angle case. If you're not sure why, just sketch a quick general triangle, A, B, and C. What do we know? We know angle B, we know side B, and we know side C. So notice that side, side, angle, okay? All right, so let's go ahead and use the law of sines to solve this, okay? So I know B and B, so I'm gonna use sine of B over B. So that's a sine of 31 degrees over 8 equals, the other part I know is C, so sine of C over 13. Solving for sine of C by multiplying both sides by 13 gives me 13 sine of 31 over 8 equals sine of C. So you're a very pretty cat, but nobody wants to see. All right, so we're gonna have to go ahead and go to our calculator for this. 31 is not a nice angle that we know. We know it should be really close to 1/2. Okay, so let's go ahead and go to our calculator to get a decimal for this. Okay, so I'm gonna share my calculator screen. And we're doing 13 sine of 31 divided by 8. So 13 sine, not inverse sine, just sine of 31 divided by 8. Okay, so we got 0.837 equals sine of C. Okay, now what do we want? Well, we want to know what C is. So in order to find that, we're going to take the inverse sine of both sides. So inverse sine or arc sine of both sides. The inverse sine and sine cancel. So that leaves me with C, which is going to equal inverse sine of 0.837. Okay? So we're going to go back to our calculator and do inverse sine of 0.837, which gives us 56.8. I'm going to round that to 57. Be careful when you're doing your MyMathLab homework that you follow whatever rounding requirements they say. So C is equal to, we're going to say 57 degrees. Oops. Okay, 57 degrees. Okay, so we know we have at least one answer, but it's possible that we have a second answer. And that second answer would come from finding, excuse me, the supplemental angle to 57. The supplemental angle to 57 I would find by doing 180 minus 57. 180 minus 57, let's see, 180 minus 50 is 130. 130 minus 7 is 123. So our other possibility is that C could be 123 degrees. So we need to check that, okay? Could C be 123 degrees and we still have a triangle? Well, to check that, I'm going to go back to my original angle, 31. If B is 31 and C is 123 degrees, so here's our hypothetical triangle. We don't know A. But if B is 31 degrees and C is 123 degrees, is it possible to find angle A? In other words, are these bigger than 180 already? No. 123 plus 31 is 154. So there's still some left over for angle A. So if these two are 154, let's see, 6 gets me to 60. This would be 26 degrees. I think that's right. So this is a possible solution, meaning we're in the case of two triangles. Two triangles. One where C is 57 degrees, and a second where C is 123 degrees. So if we were solving, we would actually have to solve two completely separate triangles. One with B equals 31 degrees, and little b 8, little c 13, big C 57 degrees. That would give us one whole triangle. And a second with 31, 8, 13, and 123 degrees. Two completely separate triangles. All right, let's look at least one more example. All right, so here's another example. We have C is 125 degrees, little c is 12.4, and little a is 7.6. So we're in the side-side angle case again. A quick sketch shows us that's true. So we know C, side C, and also side A. So that should look like side-side angle. Okay. So let's go ahead and go forth with our law of sines. So we know big C and little c. So I'm going to start here with sine of 125 degrees over 12.4. That's going to equal, the other partial we know is A. So that's going to equal sine of A over 7.6. Okay, solving for sine of A, I'm going to multiply both sides by 7.6. So I'll have 7.6 sine of 125 over 12.4 equals sine of A. I'm going to go to my calculator to calculate 7.6 sine of 125 degrees divided by 12.4. So we're doing 7.6 sine of 125 divided by 12.4. 0.502. 0.502 equals our sine of A. So that means that to find sine of A, we're going to need to do inverse sine to undo. Sorry, to find A, we need to undo the sine. So I'm going to take inverse sine of both sides, which tells me that A is going to equal inverse sine of 0.502. So again, we're going to go back to the calculator and calculate that. So inverse sine of 0.502. And that gives us approximately 30 degrees. Again, please pay attention to like my math lab and what it says you should round to. So that gives us A equals 30 degrees. So we know that we have at least one triangle. Now we need to check and see if it's possible that we have two triangles. In order to check that, we're going to look at the supplement to this angle here. So the supplement to A is 180 minus 30, which is 150 degrees. So our other possibility is we could also have a triangle where A is 150 degrees. That looks problematic to me because we already know that C is 125. Can I have a triangle where one angle is 125 and another angle is 150? No. So this is not possible, meaning we only have one triangle. So we're in the one triangle or the unique case. Okay? All right, so that's our ambiguous law of sines. It applies when we have the side, my check marks confused me for a minute, I apologize. When we have the side-side angle case, which is what we've been working through, and in that case, if we have side-side angle, three things could happen. We could have no triangles that meet those requirements. We could have one triangle and exactly one triangle that meets those requirements, or we could have two triangles that meet those requirements. We've looked at examples of all of those and kind of seen how we can recognize those things when we're doing law of sines in the wild.